Okay, math application students, we're going to talk now about sequences that are geometric, and this is an introduction. Okay, so first of all, what is a geometric sequence? Geometric sequence is when you've got a list of numbers separated by commas, and to get the next number, you can obtain it by multiplying a constant number to get it. So let's look at this example here. We have 4, 12, 36. How do we get the next number? Well, if I look at this, I can think to myself, isn't 12 simply 4 times 3? So in order to get to the next one, I have to multiply it by 3. So to get this, 12 times 3 is 36. Or think of it as 4 times 3 times 3, right? Anyways, to get the next one, we're multiplying by 3, right? So what's 36 times 3? That is 108. And 108 times 3 gives me 324. And 324 times 3 is 972. So that's how you get the next number, is you simply keep multiplying the next one times 3. Okay, times 3, times 3, times 3. Okay, so this value that we're multiplying to get to the next one is called the common ratio. Okay, so notice how I said, okay, if I go from here to here, so let's say this first value here, this value here is A. Okay, now to get to 12, I multiplied it by 3, didn't I? So the value that I'm multiplying to get to the next one is R, right? So I could call this, if I multiply the blue term times 3, 3 is my R value. So to get to this next one, I multiplied it times R. Now if I multiply this times R, we're going to have A times R to get this guy. And then the next one, if I multiply it times R, and the next one I multiply it times R, you're going to start seeing a pattern that if I know the very first term and I know what R is, I could figure out the fifth term simply by multiplying it by R. If I have the blue one and I multiply it times R, times R, times R, times R, that's 4 R's, right? So the first one doesn't have an R, the second one has an R, the third one has R squared, the fourth one has R cubed, the fifth one has R to the fourth. So basically this power is always one less than the term that we've got. So let's look at this example. Well, before we do that, so if I said find the seventh term, we would have A times R to the 1 minus, and so this would be 6. Okay, now let's look at some more examples here. Okay, to get to the next one, I'm multiplying by times 2, right? Because negative 8 times 2 is going to give me negative 16. And if I multiply that times positive 2, we get negative 32. And if I multiply that times 2, we get negative 64. So what's my R value? My R value is 2. Okay. And if I said find t to the, I don't know, let's say 6th power. Okay. Then using this relationship here, we know that A here is negative 8, right? And we know R is 2, right? And if I'm trying to find it to the 6th power, my power is going to be 1 less than the n value. So 1 less than 6 is 5. So 2 to the 5th is 32 times negative 8. That's going to give me negative 256. Now let's see if that's right. If I multiply negative 64 times 2, I get 128, negative 128. And if I multiply negative 128 times 2, I get negative 256. Okay, and that is the same as here, right? So what did we do? I took my A value, which is negative 8, and we have that here. And then we knew that R was 2, and since I was finding t to the 6th, we just reduced the power by 1. So it's going to be the R value to the power of 1 less than n. So since this is 6, I'm going to have it to the power of 5th. Okay. You may want to rewatch this again to hear it again. Okay. What if I say, what is the value of t2 divided by t1? Okay, t2 is negative 16, divided by t1 is negative 8. Well, what's 16 divided by 8? 2. Okay, t3 divided by t2, negative 32 divided by negative 16. Well, once again, that's equal to 2, isn't it? Okay, t4 divided by t3, negative 64 divided by negative 32. Oh my gosh, that's equal to 2. So what did I just figure out with this example here? What we just figured out is that for any term, I can figure out that R is equal to any term, let's call it t to the n, divided by t to the n minus 1, right? Because if I wanted to, since this is equal to 2, that's equal to 2, that's equal to 2, I could have said t to the 5th term divided by the 4th term is equal to 2 also. Or I could have said the 20th term divided by the 19th term is going to be equal to R. Okay, let's think of some more examples here. And the missing term. Okay. Well, you know that this one's going to be A, right? Now to get to the next one, we multiply it times R, right? So this is going to be A times R, right? And to get to the next one, we multiply it times R. So this is going to be A R squared. And to get to the next one, it's multiplied times R, right? So this is A R cubed. Okay, so now let's think about this. If this one, to get to the next one, I multiplied it by R, well, what did I multiply what did I multiply this? In order to get negative 3 over 125. Well, the numerator is the same, isn't it? Okay, what about, so let's put the numerator 1. Now, what do I multiply to 25 in order to get 125? 5, right? 5 times 25 gives me 125, right? Now, this is positive and this is negative, so my R value is going to have to be negative because it's changing signs every time. Okay, so now let's think backwards. To get to the previous one, if I divide by R, so first of all, we know that R equals 1/5, okay? Because if I take this value here and multiply it by negative 1/5, we get this one here. So since R equals that, 1/5, if I multiply 1/5 times 3 over 25, let's do it. 1/5, negative 3 over 25 times 1/5, my mistake. This is negative 3 over 125, right? Times 1/5. Oh, wait, it has to be negative, right? Because it keeps changing signs. Then we're going to get a negative times negative, which is positive. And 125 times 5 gives me 625. So 3 over 625. So to get to the next one, we keep multiplying by 1 over 5. And the sign is going to change. So this is positive, that's negative, this is positive. So this one here is going to be negative. The first one's going to be positive. So instead of multiplying by 1/5 to get the next one, to go this direction, I have to divide by 1/5. So 3/5, 3 over 25 divided by 1/5 is going to give me 3 over 5. Well, the next one's going to be positive 3. Just positive 3, right? Now let's see if so if 3 is my original value here for A, if I multiplied 1/5, negative 1/5 times 3, I get this, don't I? And if I multiply negative 1/5 times this, I get 3 over 25. If I multiply negative 1/5 times this, I get negative 3 over 125. Multiply negative 1/5 times this, I get 3 over 625. All right, use this to help you with your homework.